Welcome to CS1203 Database Systems 1. This is Unit 5 Lecture Part 3. And as I pointed out in Lecture Part 2, this is simply just a continuation of the discussion that we were having in the Part 2 lecture. And if you recall, we were talking about some of the ANSI SQL statements, and we had just covered the DDL statements, or the data definition statements. And we want to kind of continue on by looking at DML statements in this particular lecture segment. So DML stands for Data Manipulation Language, and it's designed to manipulate data within database objects. Now, we talked about DDL and what the role of DDL was to help us to create and manage new database objects. What DML does, it allows me to manage the data within them. So it includes statements such as the select, which retrieves information from the object or from the database object, insert, which allows me to insert or create new information in those database objects, update, which allows me to change the information in those objects, and of course delete, which allows me to remove information from those objects. Now, we're going to put select aside for just a moment. We're going to deal with it in just a few moments. And select is we're going to have a whole kind of a discussion around that because it's one of the most important and most used statements that we're going to have within all of the SQL language. And we're just going to look at a few examples around insert, update, and delete. So as we pointed out, delete is really a statement that allows us to delete data from a database object, and typically that object's going to be a table. And one of the things I wanted to point out with this is that essentially what we're going to delete is we have to delete rows. And as we know, a row is kind of what we're now calling the implementation, or what SQL calls a tuple. And so one of the things you'll recall is that we put a lot of emphasis on this ability or this need to be able to uniquely identify a tuple of information. We had to be able to uniquely identify every row. And you might have been wondering at the time, why is it so important to do that? Well, we're going to find out one of the reasons why it's so important to do that right now. See, imagine I want to go to a particular table and I wanted to delete a specific piece of information. If I couldn't, and again, let's go back and understand that SQL deals at the level of a set. So what I have to be able to do is I need to be able to articulate and define a set of 1. Therefore, I need to have some condition that allows me to identify within that table a set of 1 row, 1 piece of information that I might want to delete. Now, I could certainly delete more than 1 piece of information, but in order for me to have a functional solution, I need to be able to get down to just that 1 piece of information. Because if I couldn't do that, I might wind up deleting information that I really didn't want to delete. So one of the reasons it was so important to be able to get to a point where I would understand what the primary key is, or that set of attributes that could uniquely identify each row of information, was for this purpose of being able to identify it in order to delete it. So because I want to be able to delete a specific piece of information or many pieces of information, and I can do both with the delete statement. The insert statement is very simply a statement allows me to create new data. So it's very simple syntax. I can say insert into a particular table, and I give it the listing of all the attributes, which we are now calling columns. In fact, the way that you do this is you just give it a name of the column and comma and a name of another column, etc., etc. And then you have this statement called values, and then you literally just list out all the values or the data values that you want to actually be inserted and stored in that particular table. So, relatively simple format. We will get into a little bit more complex in the reading material, complex forms of this, because one of the things we'll find out is that I can combine this statement with perhaps a select statement, etc. Again, getting back to that ability of relational algebra to put all of those different kinds of relational operations together and create data in one table using data in another table. So the final one here is really kind of this update statement. And again, the update statement allows me to go in and update information within a particular table. And the way that we do that is I'm going to actually go in, I'm going to set a particular attribute or column here to a specific value or an expression. And again, we're seeing this where clause. And this where clause condition, again, it's one of the reasons why it was so important for us to be able to come up with a set of characteristics that would uniquely identify a particular row of information was that I might want to update one individual but not all the individuals. So I had to be able to create a where condition, a set of conditional expressions that would evaluate to one single row so that I could update a single piece of information. Moving on, we want to look at the select statement. And as I pointed out, the select statement is perhaps the most important and certainly the most used statement in the SQL language. And at its base, it essentially retrieves data from the database. However, it has a number of other roles. One of them is that, I mentioned back when we were kind of covering all the relational algebra operations that at some point in this course we would be talking about how we take all of those relational operations and we put them together and we use them in different combinations to actually manipulate and retrieve data from the database. Well, that time to do that is now, because the select statement actually implements all of those relational operations such as the join. It also can implement the select operation, the project operation, the union, the intersection, the difference, etc. So this is very important, and I actually can combine all of those different kinds of relational operations in a single select statement. If you recall, we also implemented that we always have this dichotomy, this challenge that when we start interfacing our SQL to programs so that the programs can access, retrieve, and manage data within a database, I have this problem between imperative languages and functional language. SQL is functional. Most of the programming languages that we use to write programs are in fact procedural. And so we need to have mechanisms that help us to bridge the gap between these two. And one of those mechanisms that we'll learn about in this section is really something called the cursor. So if you think back, we've talked about the fact that SQL operates at the level of a set. So in other words, I'm going to go out and put some set of relational operations together, and what's going to be retrieved on that basis is 0, 1, or more rows of information that's going to come back as a result of executing that statement. The problem is that many times our programs can't deal with more than one row at a time because they are in fact procedural in nature. And so what we actually can do within databases, we can kind of jury-rig something up. In this case, it's called a cursor. And essentially what the cursor does is that it gives us a place, a temporary place where I can take the entire result set that comes back from the select statement and put it into a temporary place, into a temporary space, and then from a procedural perspective, I can go access the rows of information one at a time out of that space. And that's essentially what a cursor does. Cursor has a couple of functionalities. One is you're defining this cursor, you're populating the cursor, which is putting the results of a select operation in it, and then I usually have something called a fetch command that allows me to fetch a particular row one at a time out of that cursor such that I can operate on it and deal with it. And then the final thing I wanted to point out is that the select statement implements the functions of sorting and grouping. So, a lot of times when we're dealing with information, we're retrieving it, we need to perhaps group it and or sort it. And to sort, I use the order by clause within the SQL select statement. And to group it, and when we start talking about grouping, what we're talking about is the ability to take information and consolidate it and or present it in such a way that it has been aggregated. And in order to do that, I use the group by, and essentially it says I want to aggregate the information using this group by clause and using a series of attributes or columns as the grouping parameters. And we have a few examples here of select statements that we'll just kind of point out. One of them here, the first example, you can see where we're actually using the order by clause. It allows me to sort this information. So whatever attributes I'm retrieving from these tables, I'm actually going to be sorting them by using the order by clause. The next one we have here is a great example of a join operation. So, and let me just point out real quickly, you notice here we're using the star or the asterisk character, and essentially this is a wildcard within the SQL language. So what this actually says is select all of the attributes from these two tables, employee and department, where the department ID of the employee table is matching the department ID of the department table. And if you recall, when we do a join operation, and I'm not going to tell you, I'll just give you a few seconds to think about it, but what kind of join is this? But in this particular join operation, we are only going to return the results where we have an attribute that matches in both tables. Now, I've given you enough time to think about it, but essentially this is an inner join. And if you recall, we have an inner join and we actually have an outer join. And so the final example we have out here is kind of an example of a left outer join. And in this particular case, we're saying select from employee, left outer join it to department. So what that means is we're going to try to match everywhere we can department ID from employee with department ID from the department table. But if I happen to have an employee that has not been assigned to a department yet, he's still going to appear in the results. So moving on, we want to look just briefly at DCL, or the data control language. And if you recall what we said about this, is it's really all designed to manipulate the permissions to database objects. So essentially, it includes two statements, which is grant and revoke. Grant gives permission on a database or object to a particular user, and revoke takes that permission away. Let me give you an idea of how this works. Imagine I have a schema that's owned by Joe. So all of his tables and objects are within this schema. Now, the only person that has access to this is Joe. So maybe I have Rick, and I have Jane, and I have Dave. And if I wanted, as Joe, if Joe wanted to give access to his information to Rick, Jane, or Dave, what he would actually have to do is he would have to grant access. So he could use the grant statement to grant access to the objects and data that he has within his schema. So the grant statement is used to give that access to external users, people that are outside the domain of Joe and outside of his schema. Revoke means that at some point in time, I've given access and I might want to take it away. So perhaps Dave moves into a different role, so he's going to actually revoke access, and Dave would no longer have the ability to access his database objects. So essentially just a brief overview of DCL. And then finally wanted to look at TCL. And what TCL is about is managing changes made by DML statements by grouping them together into logical transactions. And this works very much the same way as the undo redo that you would find in your Microsoft Word or in your OpenOffice Writer, right? And in this case we have 4 different statements. One of them is the set transaction. Basically says start recording changes. And what that basically means is that everything that I do that makes a change to the database is kept track of, but it's not actually saved to the database. And the only time that it gets saved to the database is when I execute a commit. Now, if I get all the way to the end and I figure out, you know what, I made a mistake in something I did, and I really don't want this information saved to the database, I can actually execute this rollback statement. And so, and then there's another command which is a save point, where I might have multiple points within this process that I want to be able to roll back to. Now, if you think back to what we said, this is really all about trying to bridge the gap between procedural and functional languages, or imperative and functional languages. And one of the ways that we're able to do that is by giving us kind of a way of managing how stuff actually gets committed and saved to the database, such that if I made a mistake or there's an error occurs in my program, I can actually tell the database to roll all this stuff back.